and I'll start sharing. Well, welcome everybody. I'm glad you can make it on a Saturday morning. I want to welcome you all and thank you again. And I also want to introduce you to two major figures in this first coaches clinic for the Arise drone design competition or drone design challenge. Douglas Lee is going to be presenting after I do. And he is, well, he can introduce himself a whole lot better than I can, but he's at the International School here in Dallas. And then Tony Tegmeyer is in Chicago and probably will be a host of the of a tournament in the Chicago area. And Doug is probably going to be a tournament host in the Dallas area. So these guys are important to know. Get to know them as well as you can if you're in their region. And they are full of lots and lots of good knowledge, and they can hopefully help you a lot on putting together a team and et cetera. And I hopefully will be able to help you too. And hopefully these coaches clinics will be of great help and support to you as well. So that's what we're at today. This is the first of 4 clinics. I want to just kind of do an overview of the what this is. If you missed the kickoff, and if you just need to get a little refresher on what the kickoff was, this is a high school drone design competition. So this is not your basic buy and fly competition. This is not necessarily a racing competition, although there are racing components to it. The idea of this competition is that you actually put together a drone. The drone actually can fly on its own. It can pick things up. It can drop things off. It can accomplish different types of tasks as it completes its competition. That's the purpose of this design competition. You're probably going to have to build a drone in the process. So that's what this is. That kind of separates this from most of the drone competitions that are out there now. So this is primarily high school. It's been set for high school so that it's not too easy, but it's not too complex either. So it doesn't require calculus unless you're working with Doug, because Doug knows quite a bit about how to manipulate things and make them right using calculus. But for the most part, you do not need that to complete this. And there's other competitions that are much more complex than this. We are basing our competition sort of on the SUAS competition. SUAS is not the canal in Egypt, but it is SUAS, the Student Unmanned Aerial Systems competition through AUVSI. But that is a very complex thing. And it is certainly a thing that you can get into as a high school, but this is a good way to get into that and get into those types of design things. This competition was built around a curriculum. The idea is that this is part of the school day instead of this is an after school activity. We want teachers, we've come to understand that if this is an after school thing, then teachers will burn out very likely because it is something they have to do after school, and they become what is known as competition widows. They end up not spending a whole lot of time at home, and their spouses consider them widows during the competition time. We don't want that. That causes burnout, causes all kinds of other types of frustration. We are also looking to make sure that this is authentic. That is why ours is outdoors. A lot of flying drones are done outdoors. The flying is, the intent is to go from one place to another. So we're doing it outdoors. A lot of drones, especially sophisticated drones, have sensors that were built for the outdoors. They require GPS location and other types of things. We want to make sure that we can use those types of sensors in this competition. That's why we're putting them outside. Most of the industry does that, and that's why we're doing that. This is mostly about when you're thinking of what types of learning is going on here. We are trying to teach thinking and critical thinking rather than just knowledge about the drones, knowledge about the different parts. We want the kids to be able to think. And the whole point of this is thinking rather than knowledge. This is not to take a test. It is to show that you know how to build something and build it well. And the whole idea is that this is leading to excellence, not just satisfactory progress and other types of things like that. Our competition is based on the 4 C's. These are industry standards. These come from the Secretary's Commission on Necessary Skills for 21st Century Workforce Skills. Education has kind of coalesced them into 4 pieces. They're called the 4 C's. This is all about creativity, collaboration, communication, and critical thinking. Those are the things that that industry needs and wants. So this is authentic, and it also is industry promoted and industry focused. So the whole idea of this is to make your students business ready or industry ready. So they want creativity, collaboration, communication, and critical thinking, and not necessarily school skills like taking a test taking skills and studying skills and other things like that. They want kids that can actually do stuff. And that's what this is focused on as well. This is for teachers by teachers. And this has been controversial. Isn't this for students by teachers? And it is for students for sure, but this is created for teachers so that you can use it in your classroom. And it is created by teachers. Tony is a teacher, Doug is a teacher, I'm an educator. Most everybody involved in this is a teacher, and we want to make sure that it works in schools. Everything that we do with regards to this competition is to make it work in schools. We want to keep everything inexpensive. We want to make sure that you can put the field together inexpensively. We want to make sure that you have access to the different types of playing areas, and those are typically football fields or soccer fields or anything like that. Hopefully you have access to those things as well. So it's what teachers would typically have access to in an inexpensive way. So we are teachers. If there's anything we can do to make teachers' lives better, that's what we're all about. This is a competition about a low floor and a high ceiling. We want to make it easy to get in. We want to make it easy to compete. But if you want to win, there's a lot you need to understand and be able to implement in your drone. So it's you should be able to easily get a drone, put the drone together, and be able to compete without much difficulty at all the first time you do it. Hopefully you'll learn a whole lot from the other competitors while doing it. But if you want to win, you're going to have to push that ceiling a bit. And you're going to have to understand how everything works together and design it just to work optimally for the game that we're playing. But it shouldn't be hard to play. It shouldn't be hard to get involved. It shouldn't be hard to be part of this competition and part of this community. So that's what we're aiming for. This is for teachers in the classroom. You're going to find out a little later that the next coaches clinic is all about curriculum and how to use this in your curriculum, how to use this in your classroom, where it fits, what kind of a class, and how to get it approved by your school board and get it into your school that way. So that's the intent of the next coaches clinic. We're not going to talk about it so much here, but the idea is that you don't have to just do this after school. This is not just about flying, although it it requires a good pilot. You probably will need a good pilot, but this is about engineering your drone. So it's design, and design is something that everybody does. It's not science, it's not math, where you're pushing the boundaries of knowledge in science and math and our understanding of the world. This is the application of the science and math that you should be learning in all the other subjects. So this is applying science. This is applying the math. This is what most people in the workforce do. If you're a doctor, you're not necessarily pushing the boundaries of knowledge. You're typically applying what you understand to the to fixing people. This is an architect is not necessarily just knows the science and math. They have to apply it to make a building work. This is mechanical. This is engineering with a very big E, because this is creating something new, creating something that works better than something else. It's an iterative process. It is a unique process within engineering. So the process of science is the scientific method. The process of math is the problem solving, and the process of engineering is design. So that's what we're promoting here. And we think that it's very, very important, because almost every job out there is probably looking for someone who can apply math and science rather than pure scientists and mathematicians. If you look online at any of the hiring sites, you're going to find a lot more jobs for engineers and applied scientists than for scientists and mathematicians specifically. So that's what we're trying to do. So there are going to be a number of these coaches clinics. This coach clinic is primarily about team management, which is what I'm presenting on, and which I find is the most important for you as the coach. Maybe it's because I'm the one who's presenting it, but it is what you need to do and what you need to make happen as a coach. And then Doug is going to talk to you about the hardware, and that's the knowledge of what you need to do. And then the next one is going to be on drone curriculum, and then a little bit more on the hardware and how to implement, to teach it in the classroom using the hardware that's in drones. And then the next one is drone communication, which isn't communication among your team, but that's communications via radios. That is very complex with these drones. You need to understand transmitters. You need to understand receivers. You need to understand conductivity. You need to understand a lot of stuff with regards to the radios. Those are going to be a challenge. And then the software that goes with it. So we have an autonomous competition, an autonomous challenge. You're going to need to be able to find waypoints. You need to be able to have your drone work in an autonomous manner. So there's a lot of autonomy to your drone. You need to understand the software that way. You need to calibrate your drone so that it doesn't tip over, that it's balanced, that it can handle the things that you've added to it. Once you add things to a drone, then you have to reset the entire drone so that it works properly. So you need to understand the software very well. You need to understand the radio very well. And then the last one is managing your tournament. So how do you get there? How do you, what do you focus on while you're there? How do you make sure that you're prepared for when you're up, when you're ready to do your competition, when you're ready to have a match, what you should do and what you should never forget. Like make sure your batteries are always charged, and make sure you know when the next your next challenge is, and be ready for it. And if there's a conflict, make sure you go and tell the people who are running the competition so that you don't get behind. So all of those things are very important, and that's going to be in the 4th coaches clinic. So the next coaches clinics is December 18th. The next the next two after that will be in January. But hopefully you can attend those, and hopefully those will be very helpful in your participation in the competition. So this clinic is going to help you understand what to do first and how to organize things. This is what you do before you panic, and get everything ready and working and organized for your team. Because you are the manager of this team. You are managing this team, which if you talk to managers, they will sometimes tell you that they don't do anything. And to a certain extent, that's true. You don't touch the drone. You probably don't want to touch the drone. You don't want to be designing the drone. You don't want to be working through all the problems of the drone. That's for your kids to do. You are the manager. So if you talk to like Tony and you talk to Doug, the better a manager is, the less the manager does. But the managing is very, very important. It's critical at this early stage, because you are doing lots and lots of organizational things. You're facilitating things, you're planning things, you're anticipating what kind of obstacles are coming up, and you are motivating your student team to do the right thing and continue to push through and make sure it gets done, because it is very, very important to show up. You're going to hear that more and more as we go through. Once you commit, it's important to show up, because that teaches your kids it's important to do that. And it also, just by showing up, your kids are going to learn a ton from the other teams. The other teams love to brag. The other teams love to troubleshoot your drone as much as they want to troubleshoot their own drone. So if you just show up at the competition with a drone that barely works, you are going to learn a whole lot. Make sure you do show up. It will mean a lot to your kids as far as commitments go, and as far as the learning trajectory that they might go in. It'll show them how exciting it is. It will show them what they need to do to be successful the next time around, et cetera, et cetera. It's just the right thing to do. Okay. Then it's important to understand the hardware. Doug is going to tell you a whole lot more about the hardware in just a few minutes, but those things are all important. That's what this coach's clinic is about. I'm going to tell you the most important stuff, of course, which is the project management, and Doug will tell you about the hardware in the second part. So project management, what I'm going to talk about in my section is going to be organizing your teams. It's going to be project planning, what you do to make sure that you are ready by the competition time. And it requires supplies facilitation. So that's going to be very important with regards to Doug's presentation on the hardware part. And hopefully it'll help you understand how to anticipate problems and to maintain the motivation, and when you need to maintain the motivation the most. So that's what I'm going to be presenting on, and Doug will be doing the hardware. So safety is critical in drones. You need to be very, very careful with drones. There's a lot of moving parts in drones. They move as a big old thing, and these can be 20 pounds. The drones can be 20 pounds. And if you know your physics, you understand that inertia increases at a exponential level rather than a linear level. So your equation there is mv squared. So the faster your drone is going, the more damage it's going to do. It's going to go velocity squared in damage and force. So be very, very careful with these drones as they move. But you also need to be careful of the propellers. The propellers are the spinning part of the drone. they are, you need to be careful of them, because the propellers, the bigger the propellers get, and the bigger the motors get, the more damage they can do to fingers and other types of and clothing, and then parts of your school, your classroom, and other things like that. So you need to be very careful of the propellers. The propellers that we're using and the motors that we're using aren't going to cut fingers off, and they're not going to hopefully do any permanent damage. But you need to protect your eyes. So it's very important to have eye protection. And one of the things you really need to be careful of is don't get your hair anywhere near those propellers. So if you've got girls on your team who have long hair, or boys with long hair, or anyone who has hair issues in general, you got to keep them away from those motors, because those motors will suck that hair right in. And if you don't have a pair of scissors, the student might be wearing your drone as they go home. So please be very careful of that. So you need eye protection for the propellers. You need eye protection in general for flying parts. If that happens, your eyes are clearly the most sensitive parts of your body. Don't stick your fingers in the drones or near the drone propellers. It will cut you, and it will cut you badly if you're not careful with those propellers. And that's why we say, if you're going to test your drone indoors, take your propellers off. That just saves you from any kind of trouble with the propellers, but it's not going to help you with the hair. Those little, the axles will still suck in hair pretty well. So you need to hold your hair back. You need to it's kind of shop 101 safety. Do be careful with these things. Don't let your students do things that could be stupid. Make sure they take safety quizzes, and make sure that they, if they don't pass those safety quizzes, that they don't touch the drones or get anywhere near the drones, because they can get themselves hurt. And that's not okay. It shouldn't be okay in your classroom. It's not okay with this, with the tournament. If you do scary things at the tournament, that will disqualify your team. So make sure they get in the practice of being safe and doing things properly. Batteries will catch on fire. These are lithium batteries. You don't have to use a lithium battery, but lithium batteries will burn. If you, it may be counterintuitive, but they will catch on fire most likely if you discharge them more. If you see any puffiness in your drone, in the batteries, don't cut into them. Don't try to relieve that pressure, because once the oxygen connects with the lithium, you will have a big fire that can't go out. It will not go out with a fire extinguisher or any typical thing, because it becomes a chemical fire. And it's important to have battery cases with you, so that you can put your battery in there if it starts to catch on fire, so that it doesn't burn anything or burn anyone, or catch, if you're in Palm Springs, it doesn't catch a forest on fire or something like that. So be very careful of your batteries. The batteries can get hot, and they can catch fire, in fact. You won't be able to take them on the airplane, by the way. I don't think. Motors will smoke and burn as well, so be careful of those. Hopefully that won't be happening, but if you get a bunch of hair in one of those motors, they may stall, and if they stall, energy will continue to flow through those motors, and as that energy flows through those motors, they will get hotter and hotter and hotter if they cannot move, and then they will just burst into flames. So be careful of the motors. They could also be trouble for you. Drones should not be armed when they're being worked on. So don't allow the radio to be connecting to your drone when you're working on it. Make sure that everything is off. Once again, because if these things start to take off on you inadvertently or otherwise, You don't want that to happen. It could cause lots of damage and danger. So making sure that your drone is off and disarmed is very important. So you're going to learn a little bit more about what arming means. You've got a radio, and then the radio is connecting or binding with the drone. Make sure you don't have a radio bound to your drone while somebody is right over it or anywhere near your drone. Okay, drones may not respond the way you expect. That's kind of like a software rule that everybody seems to know or is getting to know if you do software, which is a drone will do exactly what you tell it to do, not necessarily what you want it to do. So you need to be very careful about the radio system. Make sure that you know what you're situationally aware. So the drones will start to act very poorly in a misty, rainy situation. They will not do what you want them to do necessarily in a windy situation. So be aware of those things. And if you have power lines anywhere near your school, try to avoid those, because power lines have EMF and they can they will interfere with your radio signals. So be careful of that. And you need to be able to knock your drone down. It needs to have some sort of fail safe that it turns itself off immediately and it comes down. It may break, it will crash, but that's a whole lot better than it wandering off and hitting a car or running into a house somewhere or hitting some person. So it needs to be able to come down immediately. So that's a part of your safety protocol, is to be able to bring your drone down on command. So that's critical, because we're going to be outside. Your drone can run off. If you leave it inside, then it's just going to crash against the wall and come down and all is well. But outside, it may not be able to crash into anything and you could have troubles. So you have to be very, very careful with that. That's the kind of the safety rundown. There's a lot more safety that you should probably be aware of, and you'll learn along the way. But do be safe in handling this. So regulations are second, because regulations are extremely important. Safety is first. Regulations are second. FAA is going to be regulating these outdoor competitions. I don't think it's going to be a problem for us, because with regulations, they're becoming looser and looser every year. Suez has their competition on a Air Force base that they can lease out. And that's because it's not regulated by FAA. But we're going to be regulated by FAA. And for the most part, that just means we need to have a pilot in command, which means that there has to be somebody with the Part 107 certification. It looks like there might be some questions out there. Does anybody have any questions about this so far?
We just had a question from Mike Cronemiller to get him hooked up with someone from New York. So
oh, okay,
that's really it. And me saying, adding that you can do this as a club, especially the first year.
Oh yeah,
like I'm doing. We want to have it be a class, and we are creating a curriculum, but you can certainly do it after school. I'm doing mine a couple of days after school until I can get it to be a class in my school. So that was it. That's the chatter.
Yeah, and Doug and Tony, interrupt anytime you want, so that to clarify what I might be saying, or to add to whatever I'm saying. So feel free to do that. Yeah, that I anticipate that this year, because you may just be hearing about this or something like that, that this is likely to be an after-school program for you in your first year. But in the future, hopefully you'll be able to build it into a class of some sort. And we want to be able to help you make it into that class by connecting it to standards and providing you the information you need to tell your school board or your school or your state board that this is a rigorous academic class, as well as a really fun activity. So you probably will need to get to know your FAA person in your area. You probably want to just call them up. It's far better to be calling them than have them call you. Because when they call you, it's generally not a fun conversation. But if you're calling them, it could be a fun conversation. So highly recommend you do that. They will be impressed that you're calling them and making sure that you are safe and your students are safe. So call them up, tell them what you're doing, and they probably will allow you to continue doing what you are doing and probably encourage what you're doing as well. But you do need to be careful of the airports in the area. There's a really good piece of software or an app that you can use to identify if you're in airspace that you have to be careful of. For the most part, you have to fly under 400 feet. So it's not typically a big problem. There is a trust certificate that all of your students should get. T stands for the, R stands for, I can't remember the R right now, but U stands for UAV safety test. So the recreational UAS safety test. It is an easy test. There's lots and lots of free courses you can take to get your trust certificate. Once you've got it, then you can fly. But it doesn't give you all of the things that you need for Part 107. Part 107 is a bit of a issue with teachers and with on the UAS, in the UAS world, because Part 107 is created by the FAA and it was built on the airplanes and a flight tests. And so it has a lot of things that you really don't need to know if you're doing UAS. Like, you need to understand flight patterns to get your Part 107. You need to have aviation charts, which you typically wouldn't need to read if you're flying drones. It requires you to understand weather patterns and all sorts of things that are very important for pilots, but not so important for UAS flyers. So teachers don't like this part because it's dry and it has nothing to do with flying a UAS, but you probably need to have a number of people getting the Part 107 in your class because it's going to allow you to do other types of things. It is required with these drones, the size that they are, anything over a half pound, in fact, has to have their serial number on the outside of your drone. So, and you have to register your drone with the FAA. So that's one of the things you need to do to compete. And you probably should have a pilot in command on your team somewhere. So a pilot in command is a person with a Part 107 license or certificate. Pilot in command is someone who is responsible for the drone. Once again, this is a bit tricky, and teachers have already complained about this because they don't want to be responsible. They prefer that the school be responsible, and anything that they do, they want to make sure that it's sort of under the liability of the school rather than the teacher. So if you become the person with the certification, you are the pilot in command, you are responsible for their flying. You should probably have a little bit of a conversation with your risk management department at your school district to make sure that they are covering you and your students if something might happen to you. If you're indoors, everything's fine. If you go outdoors, it's a little different. Does anybody have any questions about regulations that you're going to have to work under? We're all good there? Okay. You always have to watch for airplanes or any kind of flying vehicle that has humans in it. So be careful. You have to fly your drone in line of sight. You cannot go beyond your visible line of sight. B, BVLS, BVLOS are things that drones need to do in the future, but you cannot do that just yet with the drones that we have. So they have to be within line of sight. You have to be able to see it. You probably need to have somebody flying the drone and then somebody watching the drone within line of sight when you operate the drone at all times. Okay, other things you should plan for as a teacher. You should expect a crash. We've been told you should expect a catastrophic crash. And a catastrophic crash means it's a catastrophic for the drone, not for anyone else. But you should expect for things to break on your drone. Therefore, you should make sure as a teacher, as the manager of the team, that you have funds available to buy extra parts. And you should be prepared with extra parts because you probably will need them. You'll probably need new props. You'll probably need new motors. You probably need a new body at some point. So typically the chassis are snapped together pieces. If they are snapped together pieces, then you just have to replace the arm, or you just have to replace the landing gear or something like that. Those are the things that break the most. But if they're separated a little bit, then you only have to change out those pieces. But you should be prepared for something, a crash. These drones crash. That's kind of a rule. That's one of the laws of drones. Drones crash. Radios are fickle. There's lots of things that can get in the way of radio transmissions. There's actually some really good apps that you can use on your cell phones to see what kind of radio transmissions are happening in your area. Your radio transmission is not the only radio transmission out there, and they may interfere and cause weird stuff to happen to your drone. So you kind of you should expect your drone to crash, and you should expect weird stuff to happen with regards to radios, because that probably will happen. And there's a lot of reasons for that, and you should identify when what those reasons are with regards to your drone as quickly as you can, because they are fickle at times, and the radios can be an issue. An FCC technician's license is helpful here. An FCC technician's license sets you up for being a ham radio operator. Ham radio operations is a really cool thing to have, especially in an emergency. And it's probably a good thing to consider with somebody getting a technician's license on your team, because you're going to be using radios so often. So one of the issues that you need to be careful of with the radios, the most likely thing to happen that makes your drone be weird, is that your antennas are somehow communicating to the wrong thing. So your antennas, you need to isolate as much as possible. So you've got a number of antennas on your drone. You're going to have the receiver transmitter, or the transceiver, which is very important and with regards to communications, but you'll also probably have a GPS antenna as well. So things interfere with antennas. The motors are going to interfere with your antenna. The batteries are going to be interfering with your antenna. So anything that has electricity flowing through it has the potential for interfering with your antennas. So it's important to isolate them as much as you can. Get them away from the body, get them away from the batteries, get them away from the motors as much as possible. And away typically means, a foot or something. But you just don't want the drone to become an antenna that is going to compete with the little antenna that's on your transmitter and other types of things like that. And one of the biggest issues with that is that carbon fiber conducts electricity. So you're probably thinking that carbon fiber is a wonderful thing for drones to be made out of, and that is true. But carbon fiber conducts electricity. And because it conducts electricity, once again, if you are close to, if your antenna is connected in some way to your carbon fiber body, then your antenna gets all wonked out, because it, instead of being a small antenna, it suddenly becomes the entire drone. So you need to be careful of the materials you're building your drone with. If you start making it out of aluminum or something like that, then you've got an even better conductor, which means you need to be even more careful with your electronics. The motors are putting out really dirty EMF things. If you're as old as me, you know that if you turn on a vacuum cleaner, it typically will mess up your TV set, because the motors in your vacuum cleaner were sending off signals, actual radio signals to your TV to mess up your TV. But now with capacitors and other types of things, they've been able to limit the amount of dirty energy coming off of dirty radio signals coming off of motors, but they still kind of dirty signals coming off of them. So be careful of that. And stay away from high power lines, because those high power lines are giving off lots of EMF by themselves. They will cause your drone to do weird things that you don't understand or want them to do. And it could get them into trouble and cause you to put it into a intentional crash, which is never good for the drone, but it's probably important to be able to do once again. Redundant radio receivers and transmitters is always a good idea. It is a requirement within SUAS. I don't think we're requiring it yet, but we may end up having to do that. But that's, if you can do it, it's probably a good idea. Multiple drones will also cause problems, so be careful of that. If you've got multiple drones that you're flying, that's a great thing, because you have a lot, you can try different things on the drones, but if you fly them at the same time, you have to be careful that they don't interfere with each other. So once again, certifications that you can use in your class would be the FAA Part 107 and the FCC Technician's license. Those are all good certifications. If you're in Texas, it's all about getting certifications for your students. These are two of them that certainly would be useful for this competition. So you've decided to get into this competition. You want to start the competition. You want to start by finding a team, finding a bunch of kids who want to do this. Typically, that's not a hard thing to do. If you just say, we want to have a drone competition, you probably will get lots of students who are interested in doing that. So you need to pick them wisely, and they need to understand the requirements of being on the team. And it's a good idea to make those requirements, put those requirements out front. So if you're going to meet once a week, or if you're going to meet in class, they have to commit to that. It's very important they commit to that, and very important that you commit to the competition ultimately at the end. So you're probably going to have a lot of diverse talents. You want them to be different. You don't want them to be have all of the same skills, because this is going to require a bunch of different skills. So you need to identify specific roles for everyone, because this is a team sport. It's not a group. So what's the difference between a group and a team? Well, when I was doing group work, when I would assign group work as a teacher, I was never really sure if the group actually got it done, or whether one person got it done and then turned in an assignment for the group. The difference between a team and a group, in my mind, is that a team is made up of individuals who are responsible for specific roles. So on a baseball team, there's a specific role for the shortstop. If a ball goes to the shortstop, the shortstop has to field it, not anyone else on the team. The shortstop has to field it. And if the shortstop doesn't field it, one, you know exactly what happened. and who to blame, and you know where to work on development with regards to your team. But you should come up with specific roles for everyone and give those roles to each individual on your team. So you probably will have some people would be responsible for the drone chassis. Some on your team will be responsible for the electrical component of the drone. Some will be responsible for the radio. So you're going to have a good sized team. It needs to be about 20 to 30 kids, perhaps. But they're going to have specific roles with regards to building the drone and making sure that that works. So those things need to be communicated to the kids. If they have a role that they're responsible for, they're likely to stay on your team because they feel important. They feel like they're needed. And that's important to instill in all of your students, that they have an important role on your team and that they have to be there. And if they're not, then the team is going to suffer terribly. So give them roles, develop a captain, have captain of the electrical team, captain of the drone, the chassis team, captain of the radio team, captain of the attachments. So there needs to be roles given to everyone, and those roles have to be important. The more important they are, the more likely you're going to keep your students engaged. Okay. Everyone must communicate very well on your team. So I just told you to give individual responsibilities to everyone. That's fine. They need to do their individual task, but they have to work with everyone. They can't go all tangential with you on their role. They can't create some sort of a beautiful electronics piece that doesn't fit with the rest of the team. So everyone needs to continue to communicate. You don't want them going off on their own and building something that has nothing to do with the rest of the team. So they have individual roles, but they're part of a team and they need to communicate really well. And I hate to be kind of biased, but if you want to communicate well, typically that happens with girls. Girls communicate much better than boys, in my experience. Boys like to play with the toys, and the girls often are better communicators and end up rising to the top of the teams as the captains because they're keeping the communication going well. But that doesn't mean that the boys don't need to learn how to communicate better. And that doesn't mean that all girls are good communicators either. So, but you may find some really good roles for girls with regards to communications across all of the platforms. And that's, don't think of that as a law. It's just an observation that I've made. And it's been a bit of my experience. With regards to your teams, there is a process and a procedure that all teams go through. You will notice this probably. There is a forming portion of team development where all the team members kind of respect each other and are being deferential to each other. And that quickly moves into the storming, which is when they start to find their niche and start to decide that this is my area of expertise and I know what's right and you don't know what's right. And there's typically a storming process where people are carving out territories with regards to how the team works. And that can be a very volatile time. And it's important to manage that well as a coach. Then there's the norming component. So you want to move quickly through the storming and go to the norming and say, okay, this is your section. This is what you're responsible for. You make all the decisions in this area. You don't do all the work, but you make all the decisions in this area. And then that will lead into a good an effective performing team. So there is a process with regards to teaming. There's a lot you need to be careful of as a coach with regards to building your team, managing your team, and promoting a good process with your team. And there's also project planning. So project planning is what design teams do very well. And project planning is critical in what you do, because you need to plan their semester. You need to plan their competition time. Because if you leave it to them, they're likely to make rookie mistakes or other types of things. Typically, kids don't get a lot of planning experience in classes. Typically, they're told exactly what they need to do, and then they do it, and it's done. In planning for your competition, you need to consider the plan early on, and you need to create a plan that's effective, and you need to make sure you can manage your time well. And that requires things like Gantt charts. So you just say, between this time and this time, this has to be completed. Between this time and this time, this has to be completed. All a Gantt chart is a calendar and when things get completed. If you leave it to the kids, they often will say, oh, we've got time. We've got 3 months before this competition. So let's play with drones and let's fly the drones around and learn how to fly. And we'll get this done sometime within the last month, or worse still, they might think that they can get it all done in 2 weeks, which is not going to happen. Just throwing that out there. So Gantt charts are good for project planning. There's also agile planning and other types of systems engineering things you can get into. But you need to kind of map out what's going to happen in the next 3 months or whatever time you have before the competition happens, so that your time is used effectively. If you try to get this done in 2 weeks, it's not going to happen. So you need to get things done. You probably want to integrate into this things called critical design reviews. If you have mentors, that's wonderful. Critical design reviews are when they are important, when it's very important to have your mentors show up. So you develop a design for your drone before you've even put it together. That's a good time to have some engineers come in and have your team present to those engineers and say, this is what we're planning, and then get some feedback from those engineers on, is that a good idea? Is that a bad idea? Are there things that they did or did not think about in the planning stage of putting your drone together? And then once they have the drone, the prototype drone, because you never ever get it done right the first time. There's always a way to improve it. That is a law. So expect that law. It will not work the first time. So it's important that you plan to have a working drone somewhere in the middle of your preparation for the competition. Because if you get your prototype done in the middle, then you have a lot of time to fix it, because it's not going to be very effective the first time. That's a law. That's the law of design. That's kind of the law of this competition, and the fact that your kids may have never put a drone together. It is a very sure law. So you need to be very careful there. You need to have a working prototype halfway through, and then you can improve it. And that's a really good time to bring in a critical design review, bring in your engineers, have them look at it, have them work through what needs to be improved. That's very, very important as well. And then it's also very important to, after the competition, to discuss what went well, what didn't go well, what can be done better next time, type of a thing. So if you want to learn more about drones, there's some really good websites that can teach you all about the different parts of drones. Once again, I think what your job is as a coach is mostly the manager. You have to facilitate things. You have to anticipate what is going to happen going down the road with regards to planning. You have to plan, you have to be the planner, and you have to motivate your kids. So one of the things that you will probably become very aware of is that there is a drone, or excuse me, a design process, or not a design process, a design timeline that happens with every design. There's the excitement of building your drone and the excitement of a competition and everything else. And that actually is a very exciting time at the beginning of building the drone. And then you find out that that's not going to work, and that's not going to work, and that's not going to work, and that's not going to work. And it kind of causes a very big dip in motivation. And then you get closer and closer to the competition, and the excitement builds again. You've built something, things are becoming more and more successful, and the competition is coming, and so the excitement builds again. So your job as a coach is to be aware and cognizant that there's going to be a dip, and it's going to be a real dip in motivation and everything else, and you have to help them through. Be aware of that dip, and if it's a deep dip, they're going to do one of two things. They're going to persevere and move into the upward motivation again, or they're going to quit. So if they're on the verge of quitting, bring in those engineers and have those engineers help them, or bring in some information or do something to get them motivated again so that they can start on that positive trajectory again, because that is an important part of being the manager. It would be nice, and in years to come, you want the students to understand the planning and the management of your team. But in this first year, you're probably going to have to do a lot of that facilitation, anticipation, planning, and motivating. So all of those things are kind of very, very important for the coaches. Knowing how the drone works and all of that other stuff, the kids will probably work really hard to understand and to be able to do. And they probably don't want you messing with the drone too much. They want to do that, and that's good as long as you manage it. If something is not going well, bring it to the attention of the entire team, and the entire team will find a solution together. And that's the best way to do it. Stepping in and finding that solution for them and telling them what that is probably not a good idea for you as the coach and manager of the team. So once again, there's some really good resources that are available for you. This Drone Omega I have found to be extremely nice. It's you go to the quadcopter basics, and it will tell you how to fly a quadcopter. These are ideas on how to practice flying and to become a good pilot. Advanced quadcopter battery guide gives you all kinds of information on batteries, motor essentials, propeller basics, different types of drones you can get involved with, repair and maintenance tips. This is a very good site for all of those things. If you can find these resources. This was just a Google search away. If you do Drone Omega, you will find this. There's lots of good resources out there, but you should have a basic knowledge of the hardware, and that's what Doug is going to go over with you right now. Doug and Tony, do you think we should take a 5-minute break and then?
Yeah, maybe a 5-minute break, and then we'll start into it again.
Okay, so let's take a 5-minute break, and then we're going to get right into it with Douglas Lee from the International Academy here in Dallas, Texas.
So it's 11 o'clock right now. Let's come back at 11:05.
Sounds good.
Okay, everyone, we're back. Let's do this. I'm going to share my screen here, and hopefully everybody can hear me. So just let me know if you can't. So we'll start off with this. Drone parts. There's a whole lot of stuff with drone parts that you really have to be careful of. You can see here we have motors, electronic speed controllers, a frame obviously, and various radio controlled things like GPS, your transmitters, receivers, and telemetry controls. You know, a lot of this stuff might look a little bit confusing at the moment. However, it all has a purpose. So let's go into it. We have flight controllers, which is the main brains of your drone, power distribution boards, which is responsible for distributing enough current to your components, motors, frames, speed controllers to actually control your motors, batteries and chargers, your cameras and video transmitters, because you need to be able to see where your drone is going, telemetry so that you can get telemetry info from your drones, GPS so you can use autonomous flight, FPV monitors or monitors to see, to have your camera send signals to you, either a headset or a monitor or your computer. Remote controls and receivers, and a computer with a ground control station. So all of these components right here is what you would normally see in a drone like this. So let's get into it. The brains of your drone is a flight controller. So here are several types of different flight controllers, and they all do different things. You can see here on the left, there's the ArduPilot and PixHawk versions, which is what we will be recommending for our competition. And then you can see another one called NASA. That is a proprietary type flight controller. And the ones on the left, or the ones on the right, are mainly used for racing drones. So it's not typically, so all of these have different purposes, but they all basically do the same thing. What kind of things does it do? Well, ArduPilot and PixHawk, they use different flight controllers, or they use different ground control stations, and they do different things. It's not really useful for drone racing, although you can use it for that. It does have autonomous flight, so it uses a GPS and you can program waypoints and so forth. Frame sizes that it's appropriate for, anything from 350 millimeter frame and up, or even lower than that if you want, for racing drones. However, some of the boards for the ArduPilot, the APM board, it's based off an 8-bit processor, so it's not really that robust. It's discontinued, so it's not really something that we would recommend. PixHawk, okay, it's a 32-bit processor. That's what we normally use for things such as this. Although you can use the ArduPilot, it's just not as recommended because it's a discontinued model. Some of the other ones, the NASA proprietary flight controllers made by DJI, NAS 32, CC3D, or F4, F7, and H7. Those typical flight controllers are for racing, and they use a different ground control system. They do have GPS on them, but they don't do autonomous flight. You can see some of the different costs of it. PixHawk is usually around $80 to $150, depending on the supplier. And these are all open source, other than the NASA. Okay, so these are all open source, including some of these racing drones. They're all open source as well, but they're different pricing. Okay, so here, what I want to show, so I'm gonna stop presenting that and show you a different view here. Let's see. Okay, let's have a look at this. So here we go. So here you can see, focus here. There's an ArduPilot right here. PixHawk, I think this is the latest version of the PixHawk controller. It's PixHawk 5. You can, and again, there's because it's open source, you can find a lot of different vendors for this type of stuff. These ones are typical for racing drones, so you can see the relative size of it. Okay, Racing drones are quite a bit smaller, so you'll have smaller flight controllers. Some of the ones with autonomous, they have a lot more areas where you can plug in peripherals, GPS, telemetry, and so forth. So they're a bit bigger. Some of the components over here, okay, we'll go on to a little bit later. Electronic speed controllers, power distribution boards, and so forth. But I just wanted to quickly show that before I carry on. So let's go back.
Hey, Doug.
Yeah.
So the PixHawk is open source, like you said.
Yeah.
Therefore, you can, it's gone out in other configurations like NXP, I think it's NXP. They should be PixHawk compatible. So there's a lot of things that aren't called PixHawk that are actually PixHawk.
Yeah.
So
yeah. The firmware is actually called PX4. So if a flight controller supports PX4 or even Q ground control or mission planner, that's the type of flight controller that we want to use in our competition. So PX4 is the actual firmware. PixHawk is based off this particular hardware. Okay, and it runs to PX4 firmware, or it can run the ArduPilot firmware. So you can on this PixHawk 4 or PixHawk 5, you can run PX4, or you can run ArduPilot. This one can only run the ArduPilot. It doesn't run PX4. Now, this particular board is an older board, and this hardware is only 8 bits. And you know, you can find all of these all over the place on Amazon. I wouldn't recommend it, but it still works. In fact, I'll probably end up using this as a test. Anyways. Frames. There are various types of frames that you can use. You can see some of them right here. Some are carbon fiber, some are plastic, some are fiberglass. I think this one is carbon fiber based. This one is plastic with, I'm not sure what kind of platform this one is. This one I think is probably just either aluminum or some kind of, it's not carbon fiber, some kind of.
are you sharing?
Yeah, I can't see your screen.
Oh, I'm sorry. Here we go. This one. Sorry about that.
Yeah, there we go.
There we go.
Yeah.
Yeah, that's what I get for sharing between multiple things. And going back and forth. Okay, so here we go. Carbon fiber, and this one's kind of a nice little frame here because you know you can push down the arms here and carry it with you, so it's a little more compact. Probably a little more expensive. Or you can go with something completely custom and build your own frame, which is kind of fun to do. But you notice that these frames have different configurations. This one is more of an X frame. This one is a combination between X and almost an H frame, which is like this one. Okay. So to measure or know what size of frame, we usually measure between the center points of the motors from its diagonal. Okay, so an X frame would be measured like this, or an H frame might be measured like this, although this could be longer than this measurement right here. So let's take this measurement as our frame size for an H type frame. Different frame configurations. An X, square, hybrid between the two. So this is not actually a square symmetrical between both horizontal and vertical axes, but you can see that's the cross between it's more of a rectangular shape. You have an H frame and then a stretched X, which is somewhat similar to this. Okay. Quadcopter frame properties. An X frame is probably the lightest of all of these types of configurations, whereas the H frame is probably the most heaviest. You can also have the a mix between the two where it's not quite square, but not like an H frame, which is sort of a combination between the two. So it might give you the best of both worlds. Propellers. Let's have a look at how propeller properties are. Different types of propellers. You can have 2-bladed propellers, 3-bladed propellers, 4 or 5-bladed propellers. So propeller number of blades will definitely impact your performance of your quadcopter or your drone. Same with the diameter of your propellers. Okay, pitch is another thing. So think of pitch for a propeller. Think of 2 screws, one with a lower pitch versus one with a higher pitch. The way pitch works is that as you turn one complete rotation, how far through the air or how far through the material does it go? So a higher pitch has a coarser grade, such as this screw, versus a lower pitch. And you can, if you've ever used a screwdriver with a larger pitch or a smaller pitch through wood, you can definitely see that one with a larger pitch would take a little more torque to screw into the piece of wood, whereas one with a lower pitch would take less torque. But with a higher pitch, you go through more material than a lower pitch. So pitch is the distance traveled within one rotation. So having these properties, number of blades, diameter, and pitch, is very important in terms of how your drone's going to perform and how much power or current it's going to take for your motors.
Yeah, if I might throw in, this is your force, work equals force times distance formula. So the greater the distance, and the less the greater the distance, the more force you're going to need to equal the same amount of work. So work equals force times distance, the old Archimedes formula, or the work formula. This is where it comes into play. If you're going to increase your amount of distance, it's going to pull more energy from the motor. So be aware of that. But that's the formula. Work equals force times distance is the key there. And that's an easy formula to use.
Yeah. Yeah. Other thing, rotation, direction of your motors and of your blades. So you'll notice that the motors, I'll talk about direction of blade rotation for motors a little bit later, but you'll notice that your blades will come in pairs. There'll be a clockwise rotation for one propeller versus counterclockwise for another. So in your quadcopter or your drone, you'll need to have counter rotating propellers, and they will be situated at specific points on your drone. So that's another thing to be aware of as well. So here we go. If you have a standard quadcopter, okay, one blade will turn clockwise, another blade will turn counterclockwise, and you'll notice that the ones on the diagonal are turning the same direction. Okay, so this one will turn clockwise, and the one diagonal will turn clockwise, and the other one will go counterclockwise and counterclockwise for its diagonal. And that's because of our conservation of angular momentum. So whenever you have a rotating body, it's going to induce a counter torque to your rotating body. So that's why these drones have counter rotating propellers and counter rotating motors. That's something to be aware of. Now, here's a question that some kids might be wondering, and I've also wondered this as well. Inward rotation versus outward rotation. There's debate among whether we want our drones, if this is forward, we want our drone motors to go clockwise on this side and counterclockwise on this one, versus counterclockwise this way and clockwise this one. I'm unsure which one I'd like, inward versus outward. I just choose inward because that's something that I'm used to. I've heard where if you have inward rotation, that tends to throw in dust and dirt and whatever to your camera versus an outward rotation. That's what I've heard. Also, how the airflow in relation to how your configuration of your frame might impact these the rotation direction. Again, I'm not sure what the debate there is, but choose one or the other. And so in summary, for propellers, increasing required torque will increase the amount of current draw for your motors. So generally more than 4 blades will draw too much current. So you probably don't want to get to a blade that is 4 or more, or more than 4 blades. 5 blades is probably will pull too much current, require too much torque for your little tiny motor. And those are typically for racing drones anyways. To increase thrust, you want to increase the number of blades, increase diameter, increase pitch, but it's at the cost of current. So you're going to have more current supplied to your motor. And knowing that, we'll know how to size up your motors and how to size up your electronic speed controllers, which will determine the cost of your drone. Motors. Let's have a look at that.
Hey, Doug.
Yeah.
Do you want to talk about the number of blades?
Number of blades. Yeah, number of blades we have. Okay, we'll go back to here. We have 2 blades, 3 blades, 4 blades, or 5 blades. Typically, you see 3-bladed and up on racing drones. Normally, when you see the larger drones like our 350 and up or 400 millimeter frames, you'll normally see 2-bladed blades, 2-bladed drones. Okay, I have not seen blades that are 10 inches with 3, but I could be wrong. I just simply haven't searched for them. But the more blades you have, the more air is going to, more thrust it's going to give you. But with more thrust, more blades, you have to have more torque, which means that you have to have more current. Okay, so we go back to here. Number of blades, diameter, and pitch. With increasing blades, you need more current. Increasing diameter, again, you need more current. And increasing pitch, you need more current. So it's going to draw more power, or it needs more power to your motors.
Yeah, so you got a big blade, and it's going to be able to lift things a lot better than a small blade. But it's going to take up more battery power from your batteries and everything else to get it going. So a big blade is going to lift better, but it's going to go slower, and it's going to be more difficult. And if you've got too many blades on a propeller, those blades will actually start to create eddies and all kinds of other current issues within the blades themselves. So 2 or 3 makes sense. If you go up to 4 or 5, they start to interfere with each other to the extent that it's not worth having those extra blades on the propeller, from what I understand.
Yeah, exactly. And then, with those number of blades, it's going to just draw too much current for very little gain anyways. So you could potentially have maybe a 5 or 8 inch tri-blade versus one 10-inch diameter blade with just 2. But that's going to be up to the kids to consider and what to purchase, and that's going to be based on the size of frame that they have. So certainly you can't use a 10-inch blade on a 350 millimeter frame, because the blades are just going to be too close to one another. Motors, 2 types of motors: brushed motors and brushless. We will be using brushless motors on these drones, and motors are an interesting thing, because you can bring that into a good curriculum, because you're talking about electromagnetism, 3-phase motors, brushed motors, brushless motors, and so forth. So this is a nice little animated GIF that I like to show, based on the difference between brushless motors and brushed motors. And the types of motors that we choose, that drones have, is a 3-phase motor. So there's lots of things to talk about with motors and magnetism in this area. in terms of curriculum. Motor sizing. Here's where it gets kind of interesting. If you open up one of these motors, you'll notice that it's, you know, not that complicated. So we see right here, we have our iron core with a bunch of motor windings in it. This is our stator, the thing that just does not move. And then the rotor is the part that does move, that has all the magnets in it. Okay, so increasing the stator height, okay, this is your stator height, which really means you're increasing the size of your permanent magnets, okay? Increasing the stator width, which is this width of your stator, okay, you're increasing the number of coils in your electromagnet. So increasing width increases your electromagnetic coil size, increasing the height increases the permanent magnet that you're using. So increasing the overall torque allows us to spin heavier and larger blades. Now, what does that really mean? It means that a taller stator will have more power at a higher RPM, and a wider stator will have more torque at a lower RPM. So those two things that you really need to take into consideration. Now, also look into the different mounting holes and dimensions of these various motors. Typically, we see motors that have these types of dimensions for mounting holes: 19 millimeters across for one diagonal and 16 across for the other. You can get smaller motors that are 16 millimeters and by 12. And so, you know, when you're choosing motors, make sure that you understand the mounting holes of these motors, and they will come in different sizes and different motors.
So
Again,
can we do a quick quiz?
Sure.
So what type of a motor do you want for a racing drone?
Is that for me or for the audience?
For the audience.
Okay.
Do you want a tall one or do you want a wide one? Tall motor or a wide one? Brushless? Oh yeah, that's definitely.
Yeah, definitely brushless. Definitely brushless. I have some racing drone motors here somewhere. I'll bring them out in a bit.
Okay, Tricia says wide. Does everybody agree with wide? You want a wide one for a racing drone?
Well, I guess it depends on what's your definition of wide. Let's put it that way.
Well, the wider the motor, the more torque it creates, right?
Yeah. So with
The
a
taller the motor, the more speed.
more RPM at a high, yeah, the more RPMs at the higher RPMs you get. So
Which do you want for a racer?
remember, a racing drone will typically take a very small blade.
Taller, usually.
Yeah.
Yeah, something a little taller.
So you don't need it. Don't need a wide one. But for this competition, you're actually lifting. So what kind of a motor do you want would optimize for this competition? If you're lifting stuff.
So you want a lot of torque because you're going to have a larger blade.
Yep. You want to go wide.
Yeah. So
Trista is the only one doing the
wide,
chat.
tall,
What's going on?
wide. Yeah.
Yeah. So for this competition, you need to have something quick enough, but you are probably going to optimize on torque, and you want a wide one.
Yeah. We don't really care about how fast your drone's going to go. We want lift capacity.
Yeah.
So for motor parameters, size, the height and width, okay, KV value and power requirements are two other things that you need to understand. KV refers to revolutions per volt, and K refers to revolutions, and V is obviously voltage. Okay, so motor rotation is directly proportional to the applied voltage. So if you have more voltage applied to your motor, you're going to spin faster. So that's what the kV value is going to tell you. Keep in mind that as the battery depletes, your revolutions, your RPMs will decrease. So if you started off with a 12-volt battery, as you go through your mission, it's going to slowly deplete. So you're not going to get as much RPMs out of your motor as your battery starts to deplete. So the maximum unloaded RPM you can calculate based off your kV value. So your kV value times the maximum voltage will determine how fast it can go as long as there's nothing attached to your motor. So on a 1200 kV motor, which you would typically see with a 3S battery, 3S battery means that it's the maximum number of maximum voltage in a 3-cell battery is 12.6 volts. So if you take that 1200 times 12.6 volts, your maximum rotation is 15,120 RPMs out of that motor, as long as there is no propeller attached to it. Okay, so motors, keep this in mind as well. Motors are rated for either 3 cells or 4 cells, or 3 cells to 6 cells. Typically, you'll see racing drones that will be sold as 3S or 6S capable, which means that you can use a 6-cell battery, which is 22 point whatever nominal voltage. A lot of the drones that we will be looking at, a lot of the drones that is in this competition, you'll be looking at a 3S or 4S capable motor. So check the specs. Make sure you check the specs before your kids purchase or think about purchasing motors.
Just for clarification, Doug.
Yeah.
kV stands for thousands, right?
No, kV stands for revolutions. In this case, it's not thousands. K is for revolutions.
Oh, okay.
So it's kind of confusing. So, I've often seen K being number of revolutions or RPMs. Okay, in this case, it's not kilo or thousands. It means revolutions.
Oh, okay. Cool.
Yeah.
I always thought it meant thousands of revolutions.
Yeah, that's what you would think. It's not kilovolts or anything like that. It's just kV means revolutions per volt in this case. Okay, so here's another breakdown of motors. Okay, if you ever look at a motor and its model number or specs, okay, you might see something like this: 2212 Q850 kV 12N14P. What does that mean? You really want to look at this value right here. 22 is the rotor diameter. Okay, that's the stator width. 12 is the height. That's the stator height. Okay. Another important one is this value right here, 850 kV. This means obviously 850 revolutions per volt. Okay, RPMs per volt. Okay, so that's going to tell you how fast at a maximum your motor is going to give you when it is unloaded. Okay, 12N14P. It's not as important, but it's something that you should be aware of. 12N means number of magnets in your stator. So if you look at your stator, how many, you can count these: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Versus number of permanent magnets in your motor. So this number refers to how many magnets are in here: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you will often see this figure right here, but the most important ones are these first 4, 22, 12, and then this one, which will give you your maximum RPMs for the battery that you choose. The other thing to keep in mind is a lot of motors will be sold as either counterclockwise or clockwise. It doesn't refer to the rotation of your motor, because you can easily change that. It really refers to the thread direction of the shaft. not the direction of the motor rotation. So you will notice that these two motors, they might be sold in pairs and be sold as, hey, this is a counterclockwise motor and this is a clockwise motor. It just means that it has different different threads on the shaft and different colors of your of this cap, so that you know that this particular motor is spinning one way versus the other. So it's an easy way to visually identify clockwise versus counterclockwise. It has nothing to do with the rotation, the actual rotation of the motor. Why they choose to do that, I don't know. I'm thinking because, you know, if you have a motor that rotates clockwise, you may want to have, you know, a certain thread when you tie these things down, so that as it spins, it doesn't spin off this little cap. I don't know whether that's true or not.
That's
think it
my
doesn't
understanding
matter.
too, is that the propeller will actually unscrew itself really, really fast if it's threaded the same way. So
You would think so, but I haven't seen that sort of behavior in any of the racing drones, because the racing drone motors, they're all threaded the same way, the standard thread, and you tighten them down, they're not going to go anywhere. But I think that was the original intention.
yeah, so you want to put a counterclockwise, you want to run the counterclockwise with a clockwise, in a clockwise direction, so that it's essentially winding it down and tightening it up as it goes, rather than, but I think you're absolutely right that
Yeah, I think it really doesn't matter. And the analogy I put to this is that I know the FAA has done some experiments with you know, airplane wheels. As an airplane starts to land on a runway, they pre-rotated the wheels to see if there was any additional wear if you didn't pre-rotate the wheels as it landed on the runway, and the results were it didn't matter. So, you know, in this case, I don't really think it matters, and especially with racing drones. Racing drones don't have this kind of configuration. You just buy whatever, you know, standard motor and just tighten it down. It's not going to go anywhere. Anyways, be aware of that. So, what do we see? We see frame, propeller, and motor. So those three things are going to lead you into deciding what kind of electronic speed controller do you need for your motors. And what the electronic speed controller does is it controls how fast or how slowly your motor will go. Because remember, these motors are three-phase motors, and it needs some sort of way to control the timing of each of those leads. And there's 3 leads in your motor. 2 leads are energized and 1 is not. And then it goes to the next pair and the next pair and so forth. So your electronic speed controller is going to time all of that stuff for your motor. So your electronic speed controllers are going to determine how much current will be needed for your motor. And remember, your motor configuration is going to be dependent if it's going to be a 2212 motor versus using a 10-inch propeller. You're going to be drawing some current. Okay, how much current it's going to draw, we'll see. More blades on your propeller, you're going to draw more current. Larger propeller, more current. Okay, again, larger, wider, a wider motor, it's going to have different properties and how much current it's going to draw. So this is going to tell you the maximum amount of current to be drawn by that one motor. Okay, so pay attention to this value right here, and I'll show you a little demonstration of a typical motor and ESC combination. You'll also see something like this, BEC. It stands for battery eliminator circuit. What that really is just a buck converter that takes your 12-volt battery or 14.7-volt battery or whatever, and gives you 5 volts gives you 5 volts of voltage. Okay, that's all it means. It's just a buck converter. Okay, some of them don't have it. some of them do. So pay attention to the ESC that you're going to purchase, or at least make your students aware of that. Sometimes you might need 5 volts for another peripheral. Sometimes you don't. You can also get 4-in-1 ESCs, where you can see these leads right here go into the motor. So there's 4 leads that for 4 motors, and then your battery would go right here. So that's an all-in-one ESC. It can handle 4 motors, whereas something like this, you'll need 4 of these. Motor rotation.
Hey,
So
hey Doug, sorry to interrupt again,
Mhm.
but would it be good to review how drones steer? And
yeah, I suppose. Let's see how far we get into this.
okay,
Okay, let's see how far we get into this. So here's your typical configuration. You have your 2 motors, your ESCs. Now notice if these ESCs are exactly the same and these motors are exactly the same, you can hook the 3 leads into your ESC, and it's going to provide the timing for it. If you wanted this same motor to spin the other way, you just reverse out these leads. Okay, that's how easy it is. Okay, so again, it really doesn't matter whether you choose a counterclockwise motor or a clockwise motor. It just refers to the threading on the motor shaft. Okay, easiest way to swap to change direction, the spin direction of your motor is to swap the leads, or you can do it within the firmware of the ESC itself. A lot of racing drones allow you to do that. But I find just reversing the leads is so much easier for the drones that we're going to make. It's probably more advisable to do that, because you can easily just take out the leads itself. Okay.
so this is easy, but it's easy to confuse.
Yes, easy to confuse. So if you know that your motor is spinning one way versus the other, just swap out the wires. That's all you need.
And the
to
way
do.
you
Have to go into
know
firmware.
is because you'll get an InstaFlip.
Yeah, we can talk about that later. That's happened to me. That's happened to Ron as well. That happens to everybody. And it's just not paying attention to what you're doing. And that's what I tend to do. I go too fast. Okay, so here are 2 different ESCs. Okay, notice that this one on the left is 40 amps, so it can pull 40 amps quite easily for your motor. It also has a battery eliminator circuit, so it has a buck converter in here that will give you 5 volts with a continuous current of 3 amps. Okay, a lot of servos that you might want to put on your drone would take 5 amps. If a servo doesn't take 5 amps, let's say it takes 7 amps, then you'll have to figure out something else. Okay, but a lot of servos, and especially the transmitter receiver combination, the receivers on your drones will take 5 volts of current, or 5 volts of power. Okay, this one on the right is 30 amps, so it has a lesser rating on current, but notice it doesn't have a battery eliminator circuit. So if it doesn't say BEC, then you can be sure that it doesn't have a battery eliminator circuit, which means that it's not going to give you 5 volts. Even though if you look at your other lead here, this one doesn't have the red wire, which gives you the voltage. Okay, so it's easy to determine that, hey, yeah, this ESC doesn't have a BEC on it, doesn't give you 5 volts. Some of them will have the 3 leads here, but it won't say BEC. Okay, so be very careful of what you choose, because if it doesn't say BEC, it's not going to give it to you, even if it has a red wire here. Okay. Also, the other thing you need to be careful of with your ESCs is this rating right here, 2S to 6S. So this ESC will take a 6-cell battery, whereas this one can only take a 4-cell battery. You hook up anything more to it, then that ESC is going to blow on you. Okay, or this ESC will blow on you if you hook up a 5 or 6 cell battery, whereas this one can handle 2 cells to 6 cells. So that's something to be considerate of. So be sure your motor does not pull more than the maximum amp rating of your ESC. Otherwise, this ESC will blow, which means that you'll have to replace it either in the field or back in your workbench. Okay, so
But be sure you don't replace it with the same thing.
yeah. Yeah. So, you know, ESCs are pretty easy to have as a spare part. So I do recommend that you have several, you know, at least one or two as a replacement in case it blows. You will know when an ESC or a motor is bad because if you just touch it and your ESC is hot in relation to the other ones, you'll probably think, yeah, the ESC is probably bad. Or the motor, if the motor is especially hot in relation to the others on your drone, more than likely, either your motor is rubbing up against something and causing a bunch of heat from friction, whatever, and that's a bad thing, or something's going on there. So it's time to either replace the motor or replace the ESC or replace both, and that happens. The other thing to consider: do you need 5 volts to another component? Okay, such as to power a receiver or the flight controller itself. Okay, you can certainly take the power from your ESC should you choose to.
I think Trista had a question.
Yeah.
Said repeat, but Trista, what part did you want to go over that one more time?
I think he covered it with the overheating of the battery and the friction. I got it. Thank you.
Okay. Yeah. Okay, good. Yeah, that's something to be really aware of. After each flight, just check the condition of your ESCs and check the condition of your motors. Okay, if it's too hot, then yeah, something's going on here. It shouldn't be hot. It shouldn't be so hot that it burns you. If it burns you, yeah, there's something wrong with your motor or ESC or even both. Okay, so again, important to have these spare parts on hand.
And it may sound funny, don't replace it with the same thing, but a lot of times people do that. And if you get a overheated ESC or you get an overheated motor, you should consider why that happened. And if it's a problem with the motor because it's got a hair in it or something like that, that's one thing. But if you've got the wrong motor, it's important to figure that out.
Yeah, that's important to figure out. If you know, if you're using motors and ESCs the same specs forever on your drone, and you find that the ESC or motor has failed, it's probably not likely a configuration problem on your part. It's probably because the motor is either old or the ESC is old or whatever. But if it's a new drone and you find that, hey, my ESC just blew, that's when you sort of have to think, okay, did I size it up correctly? Okay, so it depends on your testing and which phase of your testing that you're in. I've had drones where, you know, been running it forever, and all of a sudden, you know, drone's not acting properly, and you touch the ESC and it's really hot. We know it's not the ESC or the specs of it. We knew it was the actual component itself. So those are some of the things you have to consider. In terms of motors, all motors will come with this type of specification. Okay, and if it doesn't, you can certainly Google or go to the manufacturer, and they have all this performance data. So the things you're going to look for are the motor model itself, and most often the motor model will have those first 4 numbers on it: 22 by 12, which is the 22 millimeters of width and 12 millimeters of height. And these are all in metric units, so nothing will be in imperial units. So I tend to have all my students work in metric rather than imperial. You'll have kV values, okay, and voltage values, okay, and propellers. So what this performance chart is showing is that for this model of motor with a 920 kV rating for an 11.1 volts nominal, using this propeller, 80 by 45, which means it's an 8-inch propeller with a 4.5-inch pitch. The current that it's going to draw at a maximum is 7.3. If you're using a larger propeller, a 10-inch propeller at 4.5-inch pitch, it's going to draw more current, 9.5 amps. But you notice it's going to provide more lift, more thrust. Okay. And finally, what kind of battery will you be using, or is this motor rated at? It's rated for 2 cells or 4 cells, and that's important. For a 980 kV rating for this same model, okay, for an 11.1 nominal voltage, again, you have the 2 props that they have. Well, this one will give you an 8.1 amp rating, maximum amp rating, and this one will give you a 10.6 for a 10-inch propeller at a 4.5-inch pitch. Okay, and again, you can see the thrust that it will provide. Okay, so this chart is going to be very, very much in play when your students actually choose the right motor and choose the propeller combinations that they want on their drone. Knowing that, okay, you get the maximum current draw for that motor propeller combination with the voltage. Okay. Oops. Once you get that, okay, now you can choose what ESC to use, because you have a good idea of what the maximum current draw is going to be. So you want to definitely be able to have an ESC rated for more than the current draw that you're going to have. Okay, but you know, how do these ESCs actually work? Well, to instruct a motor to spin, it accepts an input. And if you've done anything with servos or robotics or whatever, you'll notice that ESCs will take a PWM signal, a pulse width modulation signal, between 1,000 microseconds to 2,000 microseconds. So that's in line with a lot of hobby servos out there. So you can think of this motor as being, you know, just a servo, if you really want to think of it that way. Okay, what does that really mean? It means that within a 20 millisecond frequency, you're giving it either 1 milliseconds at a minimum to 2 milliseconds at a minimum. And this just cycles into this ESC every 20 milliseconds, or if you want to think of it, 20,000 microseconds. Okay, or 50 hertz as a refresh rate. So that's typical for a standard servo. Okay, so what I want to do now is actually give you a little demonstration of, stop that share and share. This one again. Okay, so let's do this. But I should show that. So let's move this out of the way. Quick demonstration. Okay, here is here look from the top here. Here's a motor, ESC. It's going to be hooked up to a 12-volt source, and it's just being controlled by a come on, there we go. Just going to be controlled by an Arduino. Let's move this over here, focus it a little bit more. Okay, so I'll turn on my remote. Turn on the power there. Okay, so this is actually going to give it. Wow. Okay, so my little variable power supply is going to give me 12.32 volts into this rig right here. Okay, and start it up. Turn it off again. Start it up again. Well, you know, it was working yesterday. Oh, you know what I forgot? We got to give power to my Arduino. That's why it's not going. Okay, so bear with me for a second here. Give my Arduino some power. Okay. There you go, with 12.3 volts, okay. Okay, so with 12 volts of power, okay, it's giving us 7.5 amps. Okay, now notice if I go as fast, so the burst rate, okay, is going to be upwards to, you know, more than just the continuous rate. I think we saw a number like 15 amps. Or no, I'm looking at the wattage here. Hang on. Yeah, I'm not quite sure how accurate this is. But anyways, that's something to be aware of. Okay, how much current is actually being drawn by your motor? Okay.
Yeah, it looks like when you start it up, it pulls a lot of current.
Yeah, it pulls a lot of current because remember it's the burst rate too. So you got to be careful of the burst rate. So if I turn up the voltage of this, okay, and I got to be careful of how far I turn it up. The ESC is rated for 6 cells, which is 22 volts, but the motor is only rated for 4 cells. So you can hear it. It's actually going a lot faster. Okay. And again, I don't know whether this number is accurate. I don't have a multimeter that goes beyond 10 amps, so I can't really test it out. Okay, so as your battery depletes, so you can literally hear it slow down. Okay. Let's go back to our presentation here.
So we're right at noon.
Okay, we're almost, let's, want to go through a couple more things and then we can continue at the next coaches clinic if you want. So, transmitters and receivers, there's all different kinds. Okay, which one is best? You want to, for transmitters, it's important to know there's mode 1 versus mode 2. Mode 1 meaning that the throttle is on the right side versus mode 2, which means that the throttle is on the left side. Okay, most of the transmitters that I've seen and that I use are mode 2, so be aware of that. Okay, there is a way to change it within the firmware or within the settings of your transmitter. But that means opening up your transmitter and moving one of the spring-loaded levers to the other side. So probably best to just get the right transmitter right off the bat. With receivers, there's 4 different types of receivers that you need to be aware of. PWM, which is pulse width modulation. PPM, pulse position modulation, S-bus, or DSM. Okay, those are the 4 typical ones. PWM is an older protocol. It's also an analog signal. Notice that the ArduPilot only supports PWM. PPM is also an analog signal, but all the channels are stacked over a single wire. So you only need 1 wire for your receiver into your flight controller. S-bus, which is far more robust, is a lot more popular. It's a digital signal. It supports 18 channels, and a lot of receivers will support both S-bus and PWM. Look for that. Okay, so this one, you can set it so that it's either S-bus or PWM just by pressing a button on the receiver itself. DSM is also a digital signal created by Spectrum. It is also the most robust against noise and interference. However, there's a cost to it. So these typical remotes and transmitter combinations can get up to like $300 or $400. Either one. Okay, FPV cameras and video transmitters. You can get ones that are all-in-ones like this, or camera with a separate video transmitter, or you can daisy chain if you want, not daisy chain, but chain up different cameras into another device, which is a 3-channel switcher into a single video transmitter. So you can have multiple views if you wish. So that's something you might want to consider as well. GPS and telemetry, on-screen displays. You'll need telemetry, frequencies for your telemetry modules. In the US, we use 915 megahertz. Europe chooses 433, so make sure that if you're looking for telemetry modules, you don't choose the 433 megahertz. 915 is the one we are regulated and used for in the US. GPS is all major GPS networks are supported by standard GPSs that you find for drones. And if you want, there's another thing called an on-screen display. It allows you to see telemetry information on the video signal itself. So this thing sits between your flight controller and your video transmitter. How it all works. Your drone has your GPS on here and also a video telemetry transmitter. It transmits to a receiver that's hooked up to your ground control station. Your GPS satellites are communicating with your drone. The telemetry link is also giving you GPS information as well. So on your ground control station, you'll see telemetry data and also GPS data. You can optionally have your ground control station connected to the internet. You don't have to. It's kind of nice to have it so that you have the maps on your laptop. If you preload the maps from Google, that's good enough, and that's often what we do. The electrical power distribution boards, you need a way to distribute power evenly to all your components. There's different types here. Some of the flight controllers will sell their own PDB boards, which is great as well. Or you can use something simple as this. This one only costs like $10 or so, but be very comfortable in electrical work. Batteries. Batteries are made up of 1 to 6 cells. The S stands for series, which each cell meaning that it has a nominal voltage of 3.7 volts. Okay, these cells will range from 3 volts at a minimum around to 4.2 volts at a maximum. So so what does a 11.1 volt battery mean? It means it's a 3-cell battery. What does a 14.4 volt battery mean? It means it's a 4-cell battery. So when we talk in terms of batteries, we'll either talk in terms of cells or nominal voltage. Okay, and here you'll see battery capacity, C rating, which tells you the discharge rate of your battery. The higher the C value, the faster it will give you current, or the more current it will give you in a continuous situation. Okay, and then right here, 4S means 14.8 nominal voltage. Okay, so in your battery, these are the parameters that you got to be looking at. What do they mean? Okay, cell count, nominal voltage, capacity, discharge rate. Okay, for our drones, we're probably looking at 3S or 4S, which means that you're looking at 11.1 or 14.8 nominal voltage. Battery capacity means how much current can you actually give within 1 hour. The C rating is what you want to be careful of. Okay, a higher C rating means that the battery is more expensive. What does that mean? A 30C LiPo, here's an example, means that you're taking 30 times the battery capacity, okay, which tells us that it is able for a 30C battery that is a 4,000 milliamp hour capacity. It means that it can provide 120 amps at a maximum current draw. So for our purposes, we're not going to be drawing that much current. Okay, at a maximum current draw, we might be drawing maybe, well, I don't know, 20 amps, maybe 30 amps, maybe at a maximum. So you don't really need a battery that has a higher C rating. Again, higher C rating means that the battery is going to be more expensive. Cost and weight, C rating, capacity, and number of cells will increase the cost and increase the weight of your battery. Battery chargers, I'm just going to go through this very quickly. Different types of battery chargers. You can get some complicated ones, balance chargers right here, or you can get cheaper ones. They all do the same things. Okay, it's very easy to charge a battery and to understand. Take a look at the capacity of your battery and use that as the charge current, and it will typically take about an hour to charge. Before you put anything to power, make sure you do a continuity test. Make sure you don't have any kinds of short circuits. So it's very, very important that you do that if you are inclined to have your students do a lot of soldering. So make sure you have a continuity tester or multimeter handy for you to do that kind of stuff. The other thing that you can do is you can also buy these smoke stoppers, which will detect a short in your design or in your drone and kill it right away. So putting it all together, factors that affect drone performance: motor size, propeller size, and battery size. Okay, frame and payload to a lesser extent, but these are the factors that will affect drone performance. Other factors that affect drone performance: flight controller placement and vibration from your motors, and also battery placement. So here's a typical thing to go across. If you have like an X frame or whatever, your flight controller should, be at the center line, and that's because the sensors in here, it can be really situated anywhere, but it's best to have it situated where it's the center of gravity or the center of rotation. Okay, in this flight controller, I tried looking at where the actual IMU, the sensor, is actually located within this form factor. I couldn't find it, so it's probably best just to roughly estimate. Okay, where you want to place the most amount of weight, and again, it doesn't matter where the weight is. This is just something to be not concerned about, something to be aware of. Most of the weight in a drone is from the battery, so you want your battery to be at the same plane as the rotation of your blades. Okay, you can have the battery hang down here. It'll still function because the flight controllers will compensate for all of that stuff. And if the flight controller is not located in the exact center, again, it'll compensate for all that stuff. It's just easier on the flight controller if it is situated at these types of points. And that's something that students can learn and experiment with. Other peripherals that you might want to consider: servos, okay, winches, gimbals, okay. And lastly, motor numbering scheme. That's where you might get your flipped version as you do a test flight of your drone. In Q ground control or the PX4 firmware, the motors are considered like this: motor 1 in the upper left, if you're looking down; motor 2, motor 3, motor 4. So it's going in a clockwise rotation. Whereas in Mission Planner, the motors are considered number 1 in the upper right, motor 2, motor 3, and motor 4. Whereas in beta flight or clean flight, which is more for racing drones, motor 1 is in the lower right, motor 2 on the same side, and then motor 3 down here, and motor 4 right here. So it's very important to know what motor numbering scheme that your particular flight controller or ground control station or firmware is going to be using. I did have a demonstration, but we're late on time, so I'm going to end it right there.
Okay, does anybody have any questions before we finish up? Doug went through a lot of stuff.
Yeah, there's a
there.
lot. There's a lot.
And there's actually a lot that goes into a lot of those things, like mode 1 versus mode 2 on your flight controller. Mode 1, from what I understand, is what kids are most familiar with.
Well,
So
yes and no. Most of the kids that have flown drones with me, they're familiar with mode 2. I cannot do mode 1, but Tony,
Yeah, I think
Tony is a mode 1 person.
no, I like mode 2 actually, just because of the drones that I have. I've converted to that and use that. To me, that makes a lot more sense.
but there's a lot of little things on every single one of those things that Doug touched on. So not to scare you at all, because once again, your kids will learn all about this. They want to know how the propeller works and how the motor works and how it works with ESC, and they will learn that, and they'll learn it on their own. You don't have to know it all to do this. This is like any other project management thing. Your job is to manage them, and the better you manage them, the better they'll work. Your job is management, not to know everything. They will get to know it very well. That's typically what happens. They need to know it well to put it together, and they know that, and they can get it done. But they don't know that they have to work on that in the first week of a 3-month project, as opposed to working on it on the 8th week of the 3-month project. And that's your job as the coach. So make sure that if you handle the management, they will probably have no trouble with the content, believe it or not.
Yeah.
Okay. So thank you all for being here. We have this recorded, right?
We do. Yeah. And so we will post that. So
Yes.
as you are the owner, you can download it, upload it to YouTube, or I can upload it to YouTube. Because I think depending on your Zoom settings, that recording may go away. So we will want to download it.
Yeah. Thank you all for being here on this weekend. Thank you for giving us a little bit of your Saturday. I hope you enjoyed it, and have a great week.
Yep.
We'll
Thanks,
see
everyone.
you again on December 18th.
I had one question. One of the things that you mentioned earlier was that, you have a design engineer coming in to look at the drones when they're, to keep the kids motivated. So do you assign the students to be the design engineer, or do you have someone come in from, like, let's say here we have Bell Helicopter, if we can get somebody like that to come in to look at their drones, what do you suggest?
I would suggest someone from Bell. I would suggest somebody who's been in engineering for a while. That's a great time to bring them in and have them kind of explain, did you think about this? Did you think about that? And it becomes a real learning experience. If the mentor ends up doing it, that's not a learning experience. But if they can explain to them, that looks good so far, but did you recognize that this ESC is warming up a little too fast? Well, that could be that you've got a bad ESC, but in my opinion, it may be that it's bad. It's not the right ESC to go there. So that's where the engineers can really help out the students. But a real engineer, not just a student engineer.
Okay, that's what I wanted to know. Okay, thank
Yeah.
you.
No
Okay.
problem.
All right.
Great. So if you have any other questions, just be here for one of the other coaches clinics and we'll be happy to answer your questions.
And Ken, we can make these slides available to people.
Yeah, sure.
Yep.
Absolutely.
Okay.
All right.
Well,
Thank you
I would
all
like
again.
to. Thanks, everyone. Okay, I'm going to stop recording.